So we're going to work on this. We're going to open it up. It has voltage on the chassis. We're going to test that really quick. And let's see if it's on both sides of the plug or not. Alright, we got the meter out. So these are old enough that the plug can be plugged in different ways. They're not polarized. But there's also safety capacitors in there that usually one goes across it. Let me see. So this says 125 volts on the top here. I can't read the rest. But when I put the voltage part up, and I'm going to turn on the scope. So what happens is we have voltage on it because it's leaking across the caps. On the safety caps, I think. If it's not that, then it's something completely different. I looked at this a long time ago, and I don't remember. So usually, if we look at AC, let me see here. And I hold one of the leads in my hand. You see what touching it, I can read some voltage. Okay. We've got at least 25 volts on the chassis that way. Okay. Let me just touch the back of it. So my finger's on the other side. It's 7 volts. Let's try it the other way. Nine volts. 8. I got on the screw here. I got 25. 24 volts. AC. Now let's flip the cord and see what we get. Previously we had 24 volts right here. Okay. Alright, so before we get too far into this, I want to look up the manual. I had to do something with this. I can't see anything. I gotta get this thing out of here. We go. yo100. So the yo100 and the yo101 are different. This is a yo100. Wait, I'm so tired of these contest people. Here's the schematic. That's what I need. I need to turn these idiots off. I absolutely cannot stand contesters. I detest them. They are scum of ham radio. Absolute scum of ham radio. They were bleeding all over the swap net. They did all kinds of other stuff. Bunch of douchebags. Hey, they get out on here and they cause interference and the FCC doesn't care. Nobody cares. Oh, it's a sanctioned event. Oh, okay. So what I'm looking for here is the cord where the power cord goes in. I'm not even sure. Okay, so here's this power. Oh, where's our power cord? There's lots of tubes in here. 12 AT7. What is that? A 6 AL5. BY7. That's a driver tube. 12 BY7. There's 2 of those in there. You get 2 12 BY7s, the 6 AL5, which kind of looks like a rectifier tube almost, and a 12 AT7. I don't think I'm seeing the whole schematic here. Let's go back over. There's the other half of it. Okay. Alright. So here's our cord. And we have a 0.01 and a 0.01. And they both go to ground. And most likely one of them's leaking. When they go to the 100 volt. Because there shouldn't be any reason there's voltage on the chassis at all. So, they're safety caps. They're rated at 1.4 kWv. Working volts, I guess. I mean, it's supposed to probably give some transient suppression. But I think they're both bad, and they're both leaking. And I may have already done this on this before, where I removed them, and I still had voltage on the chassis. And so, for that to happen, we would have some kind of leakage out of the transformer, I guess. Get 300 and 600 volts, 22 volts, 600 volts. Alright. So one of these are bad, it could be leaking. What is this? This is 1,000. Then it goes to ground, to cross the ground. But it would still only be 22 volts. And it would be AC that I'm reading. And this is DC, it's after the rectifier. So I don't see where it could be leaking out of the other part. The 220 volt side goes into some diodes, a string of diodes. The other line goes into a cap, another cap. That. I guess there's a bunch of caps to the ground in that supply chain, so I guess if some of those are bad, the 47s, there's 1, 2, 3, 4 of them, and I guess any of them could be bad. And then we have a 0.1. So there's a few things that could be causing it to happen, for sure. But since it's AC, I think these are pretty much rectified. Two going that way, And weird how they have this set here. Oh, that's a full bridge rectifier then. With double. With a half wave or something. Weird how they have it. Anyway, let's go back over here to this and see what kind of reading we get this time. We definitely got about 3 or 4 volts. And when I touched the other side, I got 22. And let's switch the cord. I don't think it's going to matter because you have 25. So we got more in that direction. So one of them's worse than the other. Good. Alright, well, let's get it apart. Let's see what we can find. It's probably a waste of time. Because I seem to remember doing this before. So our caps are going to be down in here. You get this cover actually can come off the back. This is a 1975. And these can handle as much power as you want to throw at them because they just go straight through. I just got the wrong screws in it. Weird. I don't remember that. These are wrong. I'm wondering if... Alright. I don't think you have to pull all of them. Maybe you do. Yeah, we do, because we got to slide the whole thing out. No shortcuts, unfortunately. That sucks. I don't remember this missing screws. I think when I got it, they weren't there. And I put those in. I don't really remember. I've had this since 2020. And it came with the 101 ZD. I'd been trying to get one of these for quite a while for a reasonable price. And it came with the 101 ZD basically for free. And at that time I had gotten rid of all the 101s I had. They sold them all. In fact, I had gotten zapped a couple of times by the previous 2 ft101 DMs that I owned. And so I said, you know what? Not doing this anymore. I think I got zapped by one of the Kenwoods too. So basically, I decided to get rid of the tube type radios, all except for my ft101 or 102s. And interesting. So we seriously have a clearance issue on the feet, which to me seems like we should be able to. I don't remember having to do this, but Alrighty. You definitely got to pull the feet. That's pretty stupid. These do not appear to have the correct screws in them. So somebody boogered with this. Yeah, they're definitely... That one's incorrect. They're not even the same size. I hate it when people do stuff like that. Booger something up. This thing isn't that way out. Oh, there's a bunch of labeled crap on here that always scares me. So these feet are okay, and the other ones are the wrong ones, and that's why they stuck out. 1500 hertz oscillator, output level. Yeah, somebody labeled these. Some schmutz on it here. Funky brown stuff. You see there's a lot of stuff going on here. Ooh, that was not good. There's some sticky crap on the outside of this capacitor. And I'm looking to see. It definitely appears to be coming from it. So that's probably needing to be replaced. There's another one over here. Looks like it might be some sticky crap on it. So these are the 47s. What is this? I can't even read it. It's a 0.1. These are 0.1. And they're... Oh, they're oil. They say they're oil. They say right on them. Oil, JCP, 0.1. 1,000 volts. This one's 1500. Interesting. So those are probably the problem. And then here's the top of your scope. You've got 3 tubes in here, 4 tubes in here. Pretty simple stuff. Small transformer does everything. You have a fuse right back here. Looks very similar to a Heathkit scope. So anyway, let me flip this bad boy over. Somebody soldered something in here. Good Lord. See that? That ain't good. So the one I'm talking about right here, it's got stuff on it. These are oil-filled caps, I guess. I'm not familiar with this, but there seems to be a ton of them in here. And I don't know why they didn't just use like this style. So I would guess That one could be aging. This is our board that we were looking at in the schematic with the diodes and the 47s, but I don't see the other 47s, so maybe they're on the other side. I don't know. It didn't look like it, unless they're inside of here. It could be. So on the input of the cord here, we've got these. I would think that they're probably these ones, but it might not be. The 1.4 kW. So what I think is probably the problem is these two right here. But when we look at our diagram, we can see these are the ones that are going to ground before it hits anything. As I recall, I removed them once when the problem persisted. See how this has just got a bar across? It doesn't matter what you do. You can run as much power as that wire can handle, and the rest is sampled. So these are feeding something. A little better look. Tone out, and then the other one is going to some other part of another circuit. So those aren't something I'm really going to worry about. You know what? I'm going to try and remove these just for the hell of it. They seem to be tagged in the middle. I'd probably want to use the soldering gun on this. It's probably going to be a little easier. I like to use a big, huge fucker. This is 240, 325 watts. I constantly have to adjust this thing. It like doesn't want to always heat up. Anyway, so it's being funky right now. There we go. You put pressure on it, and then sometimes it cuts out or cuts in. There's one of them. Alright. We've removed those from the circuit, and now let's go ahead and plug this bad boy back in. And we'll be able to actually check to see if they're conducting. God, their capacitor is going to ground, so there should only be, well, they should be able to pass AC, but not DC. So it doesn't make any sense. It bent these damn probes. Okay. Oh, we're looking at DC again, geez. Okay. So we get 12 volts here for some reason. So it's not coming through there. And if I flip the cord, we hit 17. Now, I would guess probably the simplest solution to this problem is to just put a 3-prong cord on it, but it's leaking from somewhere. Now I'm curious what we're going to get. We had a 43 passing through. And then this is one. We're passing 43 volts into the ground. That doesn't make any sense. So, what I want to do on this is just put a 3-prong cord on it. So, studying the diagram here, and I can see the secondary goes straight to the ground on the 6.3 volt side. That's AC voltage. And then we have the 22 volt, which I feel like might be the one that's leaking, but that doesn't say ground. So it's rectified through here. There's something leaking through. That's to ground. And then that's to ground. Well, what we're picking up is AC voltage, not DC voltage. This one here goes to these two caps to ground on there. That one could be leaking. This is 600 volt. Everything else is pretty much rectified. So C410, I don't know where that would be. Let me see if maybe we can C410. So here's the yo100. There's the yo101. I don't remember what the difference really is. Sweep frequency, milliamp input monitor. They have a lot more buttons on the other one. Anyway, I'm not sure I want to play around with this too much. The one that showed up as possibly being the issue would mean that probably the whole thing has got lots of issues. Let's see. So, I don't know where C411 is. It's 1,000. It looks like 35 working volts. I could replace that pretty easily if I could find it. But I don't know where that's going to be. Somebody replaced some of these. Because you can see they got solder all over the place. 4.7, 350 volt. So it might be one of these. Let's go ahead and unplug this thing. Here's a 1016. What the hell would they have done? This has got the original spaghetti on it. Let's see here. What's this one? This thing over here. Let's see if we can identify this one by doing a little voltage test. So, what I'm looking for is 30 volts DC. What I'm getting 15. That was not good. Did you hear that? This actually popped. I don't. The meter shouldn't be able to short anything. We have a problem here with this scope. You know, one of these are bad. There's 15. I'm afraid to test this with this meter, as I just heard it pop. I can't afford to mess this meter up. So I'm going to use a cheap Harbor Freight meter. But I totally heard. Okay, we're going to go 250 volt scale. DC. Okay. I heard it pop when I touched the damn thing. There's 264 volts on this one here. And I have a feeling I probably zapped my other meter. Because I don't think it reads that high on DC. Let me see if I could change the range. I really wonder why it did that. 275. So I was reading 275 after that. See if we get anything on this. Yeah, 275. I really don't like working on stuff like this. Too much voltage. Anyway, I wanted to make sure that that meter didn't get cooked. Okay. 263, so it doesn't even read close to the same. Okay. So this one here is reading 15. And this cap, I'm not sure where it goes. Let's see how long it takes for this thing to 30, 18, 15, 9, 7. Still 150 something volts in this thing. This will really get you. 100. $60 something volts stored in this fucker. $40. Yep, that's why you need to be really careful with these It's been unplugged for a couple minutes and it's still got 40, 50 volts. You're going to feel that. So what I'm trying to see here is where this one goes to. It's the only one that seems to match the description. So I can see it goes directly to, I can't read the number of the pin. It goes directly to that tube, which is going to be right next to our cap. That's going to be one of our 12 BY7s right there. So that's a different one. So there's our 4.7 at 350 volts, and then here's our 100. Well, that was the one we were just looking at. It's on the 12 BY7. So that doesn't have anything to do with what I was looking at. I don't know what the voltage should be there. It doesn't really matter. Let's see here. On the right side of this. So this is 22 volts. It actually says 20 on the thing. So when we look at that, we can see when we look at this thing, the 20 volt side of the transformer. Here there's a couple of stuff on the secondaries, and as far as I can tell, it's not on this side. See, it's 600 volts, here's 6.3, and you get 0.6 amps, whatever the hell that is. I think that might be the primary side. So I'm not sure how they had this one set up. And there's our 117. So you could go 100 or 110. So you have 6.3, you have 0, and you have 20. And so with 20 volt, and then if we look up even further in there, we have 220, which is going to be a red and white wire. The 0 wire appears to be red for that one. So we're looking at 2 orange and white wires right there. Okay. So we find our 2 orange and white wires. Where do they come up through? They totally go through there. Let's see. I'm definitely not seeing them. It's pretty hidden. Alright, there's an orange and white wire there. Alright, so they're in this bundle. And they look like they're going up over there. Alright, I traced them over to here. And it should be, I'm going to put it on 250 volts AC. I shouldn't be able to detect anything from the ground to the output of either one of those. 26. 26. So something's leaking to the ground because the output goes to that bridge and then it goes to a 405 D405 and D406, but those both go to ground. but that's going to be DC at that point. There you can see the bridge rectifier right there. You also see something funny has done something right here. I can't even begin to even guess what the hell that is. Doesn't look good. The hell would do that? Some of the soldering in here looks really bad. So we're on AC. I have a feeling that was also going to be 63 volts AC. Okay. So I don't know about any of this. There's 1,035, and I think that's our capacitor that we're looking at. Let me see if we got anything on the ground side. We're picking up 63 volts AC, 64 volts AC on the positive terminal of this one. I don't think that's normal, but I could be wrong. Alright, so that's that right there. And we're getting AC voltage on the output of this. Between the ground and that cap, there's AC voltage. And there shouldn't be. I'm not really sure what the reason would be. Maybe one of these diodes has failed. And this is supposed to be 30 volts right there, but and maybe it is. We'll have to test it. Let's go up to 250 just to be safe. Okay. Yeah, we get about 30 volts there, but why am I picking up AC on this? Is this passing AC? There's 30 volts there. I don't really want to pull that entire board, but I don't know, but that's normal. Okay, we go 64 volts. Okay, I wonder what happens if we measure a little more directly. Okay. So we're picking up AC voltage across this. Let's see what we get when we read DC voltage across it. It's normal. So I'm wondering if there's, is it just a half wave, or maybe the function of how this works still allows a half wave, because together it makes a full wave rectifier, but I don't know, it seems like that should be blocking half of the cycle and that should be blocking the other half, both directions. So why are we getting alternating current out of there? I'm not sure that that's normal. I don't know. So I think I'm going to go ahead and shelf this project for now, because I don't know enough about this to really mess with it.